Hey guys, so in the middle of this last example, my computer freaked out and shut down, so it wouldn't let me continue the same recording. So I'm going to start right where I left off in the last video again, so I apologize for that it wasn't a really good stopping place, but right now we're trying to verify the requirements for constructing a confidence interval, and the first requirement is that the sample must be a simple random sample. And I think maybe the last thing I said before my computer freaked out was that if you read the question, it doesn't say anywhere in the question, it doesn't actually verbally say that it's a simple random sample. So for number one, we're going to have to say we can reasonably assume it's a simple random sample. And the reason we can reasonably assume that is because I'm assuming this Smart Revenue Company, it's a company, it's not just some random person. It's like a company who does polls for, that's what they do, that's what their company does. So if they're a reputable company, it's going to be a simple random sample. All right, the second requirement is that n times p hat times 1 minus p hat has to be greater than or equal to 10. So this is actually a computation that we can do. So our p hat is 0.15. That's what we found in part A. And the other thing we need is n. So if we go back, our n was 3,611. So we're just going to plug that in. Our n is 3,611 times our p hat, which is 0.15, times 1 minus 0.15. And we're trying to check and see, this is like a question mark, we don't know. We're trying to check and see, is that greater than or equal to 10? So let me pull up my calculator here. I forgot to turn this back on, so it might be oriented the wrong way when I first turn it on. Let's see, yep, it is. Let's change that. Okay, so we want to do our n, which is 3,611, times our p, which was, 0.15, times 1 minus 0.15. So you can type all that in your calculator all at the same time. And we get 460.4, which is way bigger than 10. So 460.4. And it is bigger than 10. So that second requirement has been satisfied. And maybe we should check this off. The first requirement is satisfied because we can reasonably assume that it's a simple random sample. Okay, the third requirement is that the sample size has to be less than 5% of the population size. That's what this says up here. The sample size must be less than 5% of the population size. So if we look at our question again, let's see. In a survey of 3,611 adult Americans, so our sample is 3,611, and our population is adult Americans 18 or older. So we can say 3,611 is definitely less than 5% of the population. Now, I don't know the population of adult Americans, but it's in the millions, right? So 3,611, we don't need to know for sure that, we don't need to know the numbers, but 3,000, or even if we round that to 4,000, is definitely less than 5% of 6 million or whatever. We have a ton of adult Americans in the United States, so we definitely this requirement is definitely met. All right, so because all three requirements are met, then it's totally fine for us to construct a confidence interval. So it says construct a 90% confidence interval for the population proportion of adult Americans who have used their smartphone to make a purchase. So let's go back up here, read this whole thing. I just want to make sure. Yeah, okay. So I'm going to show you how to do this in StatCrunch. This one we can't just do by hand the way that we have been doing because it didn't tell us what E was in here. Now, if you click on View Example, it's going to take you the long way. It's going to have you do it by hand, but I'm going to show you how to construct a confidence interval in StatCrunch, okay? So in StatCrunch, I'll write the steps here, and then we'll do it together. So in StatCrunch, you're going to go to Stat. What a surprise, right? Stat. And then under Stat, there's a new tab we're going to go to called Proportion Stats. That makes sense, right? Because we're trying to come up with a confidence interval for a population proportion. So we're doing proportion stats. And then we're going to do one sample. And then the last step is with summary. That just means that we don't have the raw data, that we're going to use the N, the P, and the X to do it, okay? So let me pull up StatCrunch so I can show you what this looks like. Okay, so I'm going to pull up StatCrunch here. I think I have it. Yeah, okay. So, can you guys see that? No. Okay, so we're going to do Stat, Proportion Stats, one sample, and we're going to choose with summary. If we had data to work with, we would choose with data, but we're going to do with summary. Okay, so the first thing it asks us is our number of successes. So let me write that here. You know, we're going to fill in number of successes. That's two C's. I can't spell that word. Is X. And then number of observations. That's going to be your N. That's what we're going to fill in. So our X was, let's see, what was our X? 542, and our N was 3611. So when I pull up my StatCrunch again, my number of successes, I already forgot what X was, 542, there we go, is, sorry, I'm trying to get my keyboard, 542. And our number of observations is 3611. Now, we've got this pulled up. You have two choices. So we have this, it says perform. What do we want StatCrunch to perform? The first option is a hypothesis test. We're going to use that in Unit 4. We're not there yet. But the second option is confidence interval for P. That's what we're trying to do, so we're going to choose that second bullet there. We need it to do a confidence interval, not a hypothesis test. And then our question asked for, let's see, 90% confidence. So right here under level, we're going to change that to 0.90 because we want 90% level of confidence. And then push compute. Woohoo! Okay, now, I don't think it's going to let me draw on this. No, so the lower limit, L limit, is your lower bound, and your U limit is your upper bound. So we have 0.14 to 0.16. So here's our, 90% confidence interval. That's my short form for confidence interval, CI, is this. I forgot it already. I'm going to have to look. Our lower limit is 0.14 and our upper limit is 0.16. So 0.14 and 0.16. There we go. So this comes, maybe we should write a note since I wasn't able to draw on the StatCrunch. This is your, oh, not that. Whoopsies. Goodness. This is your L limit from StatCrunch. I'm just going to say SC, StatCrunch. And then this is your U limit, upper limit. from StatCrunch. That's where those numbers came from. And you always put the lower limit first in a confidence interval, or in any interval. It doesn't matter what, but in a confidence interval, the lower limit or the lower bound is listed first. Okay, interpret the interval. Here we go. This is the important part. This is like the show work part on the test. You know how it's like you do all the work, and then it's like on your paper, interpret the interval. You know, you have to be able to do this in your own words. So we're going to say we are 90%, because we did a 90% confidence interval, 90% confident that the population proportion of adult Americans who have purchased something on their smartphone sorry, it takes me forever to write on this, who have purchased something on their smartphone is between I'm going to change these to percentages because usually when we give our answer, like our interpretation, people understand percentages better. So instead of saying is between 0.14 and 0.16, I'm going to say is between 14% and 16%. But if you said between 0.14 and 0.16, that would be perfectly acceptable as well. All right, so that's our first time where we've actually done a confidence interval using StatCrunch. 99% of the time you're going to use StatCrunch. The only time you're not going to use StatCrunch is like the question we just did over here, where they didn't give you the information to do it in StatCrunch. They gave you the P hat and they gave you the E, so you can just construct it that way. Okay? Let's see what our next page has. Okay. So we have critical values and the margin of error formula. I'm never going to require you to come up with the margin of error using a formula. So that's a thing, but we're not going to do it in this class. But every confidence level is associated with a critical value, Z alpha over 2. Alpha is the complement of the confidence level. So if your confidence level is 90%, that means alpha is 1 minus 0.9, which is 0.1 or 10%. Okay? You guys remember in the last section that Z alpha was a notation that meant the area to the right. Your alpha is your area to the right. Or in this case, our alpha over 2, this is the area in the right tail of that normal curve. And we know it's a normal curve because Z means standard normal. That still means standard normal in this section. Okay, the Z-score, it looks like my notes got a little messed up here. It's called Z alpha over 2. It's called a critical value, which is the number separating the sample statistics that are likely to occur from those that are unlikely to occur. Let me draw a picture, if I can. Imagine our normal curve. Sorry that it's not a great picture, but whoops. So here's our normal curve. And the reason this is a Z alpha over 2 is because we actually have two tails. Because remember, there's a lower bound and an upper bound. And then your confidence level is in the middle. So like if we want to do 90% confidence, that would mean that the area in this middle is 90%. And then the area in the tails is alpha over 2. Alpha over 2 in each tail. So we can use the normal calculator. This doesn't have to be 90. That was just my example. whatever it is in the question is fine. It doesn't have to be 90. That was just me giving an example. So that's the level of confidence is in the middle, and the alpha over 2's are on the side. We're always going to use this right one, z alpha over 2. We're always going to use the positive critical value. Even though technically there is one over here, we're using the positive one, and the area to the right of it is that alpha over 2. Okay? All right, this table is a list of common critical values, but MyLabs Plus could ask you to find any critical value, so they won't always be in this table. So we just need to know how to do them in StatCrunch, okay? So here's an example. Find the critical value z alpha over 2 corresponding to a 98% confidence level. So what that means is if I drew my normal curve, z alpha over 2, this is because we're talking about confidence intervals, there's two tails. Whoops. You know, we have one here and one here. So this positive one is our z alpha over 2. And if it's 98% confidence, that means that the area in the middle here, all that area is 0.98. So that's the area in the middle. So we're going to go to, in StatCrunch, because this is a z, right? Z means normal. We're going to go to a normal calculator. So we did this in 8.1 and 8.2. So let's open up my StatCrunch here. I'm going to exit out of that. We don't need that anymore. So recap from before. We've done this before. We're going to go Stat, Calculators, and we're going to go Normal. Here's our normal calculator. Now, take a look at the picture we just drew. We know the area in the middle is 0.98. So we're going to go to between. And since this is standard normal, I know it's standard normal because we're talking about a z, right? A z is going to be standard normal. I don't know these two pieces in there, but what I do know is I know that that area in the middle, I don't know, you know, the z's, but what I do know is the area in the middle is 0.98. Right? I think that's what the question said. Yeah, 0.98. So I'm going to put a 0.98 right there, push compute. So that negative 2.33 is our negative z alpha over 2, and our 2.33 is our positive z alpha over 2. So if I was plugging them in right here, you know, from StatCrunch, this is negative 2.33, and then this one ends up being positive 2.33, and that's the answer. That's what it asked us for, was our positive z alpha over 2. So we got this number from StatCrunch. Now, these are really simple, except that we get all caught up doing confidence intervals and forget about this, and then we don't know what to do, and then it makes it more difficult than it needs to be. All right, let's see. Topics of discussion. What does the margin of error in, wait, what? Oh, why? I can't read. Why? There we go. Why does the margin of error increase as the level of confidence increases? Okay. So, if we want to be more confident, that our interval includes the population proportion then our interval has to get wider. And I'll show you what I mean in just a second. So, if we want want to be more confident, instead of being 95% confident, let's say we want to be 99% confident, almost 100% sure that the interval we're giving includes the population proportion. The only way we can be certain and make it more confident is by making the interval wider. So let me show you what I mean. If I had an interval, say this was 95% confidence. Remember, this is E, whoops. This is E on this side, and this is E on that side. So let's say that this was 95% confident. Now, if I wanted to be 99% confident, if I wanted to increase my confidence, my interval has to get wider to include more options so that I can be more certain that it actually does have the population proportion in it. Then notice what happens when my interval gets wider, my E gets longer because the interval is made up of two E's. So if my interval is shorter, aka confidence is lower, then my E is shorter. But if my confidence is higher, my E has to get longer to make the interval bigger. So the interval has to get wider, and then we can say, therefore, E gets bigger or increases, as the question said. My margin of error gets bigger. It means when you're more confident, there's more room for error. It's more likely that you're going to make a mistake if you're saying something with 99% confidence versus something with 95% confidence, for instance. This is the point of the class where you guys would all raise your hands and be like, I don't get it. So if that's you, just let me know, and I'll try to explain it again to you. But unfortunately, we don't have that luxury on this video. Okay, what is the effect of increasing the level of confidence on width? This is almost exactly the same question. What did we just say? We said if we increase the confidence level, the interval gets wider. So what is the effect on width? Width increases. It has to get wider if you increase confidence. Okay, why does the margin of error decrease as sample size increases? We've talked about this a lot of times. You know, the larger our sample, the larger, sample size is n, so I'm going to say n just to decrease how many words I'm having to write. So the larger n is, the closer our sample proportion which is p hat, will be to the actual population proportion. So since it's going to be more accurate, the larger our sample size, the more accurate our p hat is, the closer it is to the true population proportion. So therefore, error decreases. We're less likely to be making any mistakes because our sample, which we use to create our confidence interval, is going to be more accurate because the larger our sample size is, the closer our statistic is to the actual parameter. So that's pretty cool. All right, the last thing you have to do in this section is determine sample size. So like we just said, the bigger your sample size is, the better. But we really want to know, how big does our sample size need to be to get the right information, right? We can't just be like, the bigger the better, because then it's like, okay, well, that's all well and good, but how big does it actually need to be able to get good results? So it says, give a desired margin of error and the desired confidence level. Given a desired margin of error and a desired confidence level, we can determine how big our sample must be in order to estimate the population proportion. So here's the StatCrunch way. You're not going to do this by hand. If you click on View Example, it will use the formula, but we know we do it in StatCrunch. So we're going to have stat, proportion stats, one sample. That's almost the same as doing a confidence interval. And then the last thing you're going to choose is width/sample size. If the result is not a whole number, we are always going to round up. Even so, example, if you get n equals 271.2, then we're going to round up always to 272. Even though that doesn't follow traditional rounding rules, we always round up. Okay, I think we have one more. I think we have an example. Okay, good. I was like, I hope we have an example of this. Okay. A sociologist wishes to conduct a poll to estimate the percentage of Americans who favor affirmative action programs for women and minorities for admission to colleges and universities. Here's the question. What sample size? That means, what sample size means, hello, we don't know what n is. That's what we're looking for. What sample size should be obtained if she wishes the estimate to be within 4 percentage points? Okay. This is tricky. Within 4 means that's our error. This is our E. And that actually means that E is 0.04 because 4% changed to a proportion is 0.04. Okay? And our level of confidence is 90%. And then part A says she uses an estimate of 55%. So this is, in fact, in MyLabs Plus, they usually call this a previous estimate. Whoops. And StatCrunch is going to call that the target proportion. It's something that we've already known from the past, so we're targeting that. And that means for our target proportion is 0.55 because we want to change that to a proportion and not have a percentage. Okay, now that we've talked about all that, we have to talk about one more thing. We've got to remember, here's our confidence interval. P hat's in the middle, and we have this E on both sides. And our E is 0.04. So if we were asked the whole entire width of this whole confidence interval, not just E, that would be 2 times 0.04 because there's 2 E's in the confidence interval. The length of a confidence interval is E plus E, or E times 2. So that would give us 0.08 for our width. So our width is 0.08. Maybe I should write right here, width is 0.04 times 2. So you've always got to multiply that E by 2 to get your confidence interval width. All right, I've set it up enough. Let's do it in StatCrunch. So I'm going to open up StatCrunch. We're going to clear out of this normal calculator. Okay, so hopefully you have your steps in front of you. We're going to do stat, proportion stats, one sample, and instead of doing with summary like we did last time to do a confidence interval, we're going to do width/sample size. And we get this funny looking calculator here. It won't let me move it. Let's see. Okay, there we go. So you'll notice there's a place to put confidence level, there's a place to put width, there's a place for target proportion. So our confidence level is 90. It wanted us to do a 90% confidence. So our confidence interval is 90. Remember, our target proportion was this previous estimate of 55, so that's 0.55. So we're going to change this target proportion to 0.55. And our confidence interval width we said was 0.08. So right here under width, we have to put 0.08. Now you'll notice we filled in all three boxes except for sample size. Sample size is the one we don't know, so when I push compute, StatCrunch is going to fill that in for me. 419. Woohoo! So from StatCrunch, we get our answer. N equals 419. Yes. Okay. Second question, part B says she does not use any prior estimates. So this means our target proportion is no longer 0.55. We're not going to use this 0.55 this time. We're not going to use a previous estimate. So when you don't have a previous estimate, I didn't spell previous right before. Sorry. When we don't have a previous estimate, we're going to use 50%, or as a proportion, that's 0.50. So if you don't have a target proportion, then we're going to use 0.50 as our target proportion. So if I go back to my StatCrunch page, all of this stuff is going to be the same, except this target proportion is going to be 0.50 instead of 0.55. And then just as to be safe, you see how it rounded this width on us? We typed in 0.08, but it rounded to this weirdness. Let's just go ahead and retype that so we don't have any weird double rounding going on, and push compute. 423. So that changed it. Our N for this one is 423 when we don't use a previous estimate. Okay, question C. Why are the results from parts A and B so similar? And that's just simply because our previous estimate from part B is so close to 50%. Which is what we use as our target proportion when we don't have a previous estimate. So since it was so close to 50% to start with, this 55 was, we didn't get very different answers from part B, A and B. All right, finally we're done with 9.1. If you have any questions about this, just send me an email or call my office number and I'll be happy to help you as best I can.